All right, guys. Do this. Okay, so what I read is that we can't take the test one at a time.
Wait, what?
What the teacher posted an email to us was that we can't take the test one at a time. We have to do it all together, all at the same time.
Oh yeah, and I totally don't get the logic behind it, but I mean, I don't know. It's one of those things that is like, all right, I'll do it, but I don't really understand why.
Yeah. All right, so a few questions here.
For number 3.
We have a data file we need to see.
Yeah, here we go.
You're hearing a lot of background noise.
Yes, where I am now, there's a lot of background noise. And I don't know. That's the only place I can have internet now.
Okay. Can you mute your mic until you need to say something?
Okay.
Thank you. Now just feel free to, unmute it when you want to say something. Are you guys following along? All right.
I'm trying to see where they had to pay. Wait a second.
Wrong body part of the patient's body on the wrong patient. These are called wrong site and wrong patient mistakes. Such errors occur hundreds of times each year across the U.S. The medical community is trying to eliminate these errors, but have had difficulty reducing their frequency. In a small percentage of these cases, the patient files a lawsuit against the hospital. Phillips et al. Conducted a study on these mistakes and the lawsuits that follow. The data in the file, which is right here, represent the amount in US dollars hospital has been required to pay in wrong site and wrong patient lawsuits. Some of the values equal 0, indicating that the hospital won the legal battle. All right, first question. Find the mean amount hospitals had to pay in wrong site lawsuits. Round answer to the nearest whole dollar. That's a lot of data.
That's a lot.
Okay, so we need to find the mean. That means we need to take the number of wrong site lawsuits. So we have 411 wrong site lawsuits.
Are you counting like how many numbers are in it?
Yeah, so I'm counting all of these. So
Oh,
we're doing the wrong side because the mean is the average.
okay.
So what we do is we need to take the total. So we'll write a formula here.
Because I got a bit confused. I thought we're counting like we're summing the numbers within those cells, but I guess that makes sense now.
Yeah. 30. So in total, they paid out $32,896,000 over 411 cases. So we need to find the mean.
3289, 51.
Equals this divided by this. Round it to 3 decimal places. Right? I can remember to round to 3 decimal places. Yeah.
To come out with 841. Oh,
Okay, so that's what I calculate the mean is. Does everyone agree with that?
what was your number?
80,041.
1243.
Yeah, 80,041.
Are we rounding to 3 decimal places? I think.
Yes, we are rounding to 3 decimal places.
Well, I thought right answer to the nearest whole dollar. I think
It
you want
says
us
to
to
the
round
nearest
to
3 decimal places. Right there.
which number are you on? Number 3?
Yep.
That's weird. Instead of me to round to the nearest whole dollar, let me share my screen real quick. This is
Okay.
yeah, it's in round. So right below question number 3, like on a quiz, question number 3, I found the mean amount hospitals had to pay in wrong side lawsuits. Round your answer to the nearest whole dollar. Can you see what I'm talking about? Yeah, come down a little. So right below the question. All the way, yeah, nearest whole dollar right there.
Oh, I see. I was looking up here for this one.
Oh,
Sorry about that.
that's
So
okay.
the whole dollar would be 80,041.
Yeah.
Good catch. So find the median amount hospitals had to pay in wrong side lawsuits. Now the median is the one in the middle after it's been arranged top to bottom, right?
Yeah, I think so.
From lowest to highest.
Let's see
We
here.
need to arrange these.
This is so that'll be filter from smallest to largest,
Yeah.
and then I'll have to 411. So that would be 210. Oh, yes. If there's 411, that's around 206. Let me see.
I'm not sure how to arrange. That's
100. I'm just gonna filter from top bottom, and then probably go to cell, like count 206 cells. So the 205th or 6th cell will I divide by 2, right, to get the median. Since if it's an odd number, or if it's an odd number, you pick the one right in the middle. If it's even numbers,
well,
so it should be what, 69 in cell A208, because that's where they both meet in the middle, right?
well, there's 411 data points. So 411 divided by 2, that'd be 205.5.
So one will be 205, one will be 206. So the middle one will be just right between both 205, that one in the middle, right?
Yeah, I think so. I think you take, so cell 205 and 206. I think you average those together.
Yeah. Let's see here. 205. 205 and 206. So it wouldn't be cell 207 that is smack in the middle. We'll have to get an average of the two in the middle. Is that what I'm getting? Let's see.
319. Okay, so what I'm thinking is, okay, what I did here is we have 411 data points, right?
Mm-hmm.
We divide that by 2. That gets us 205.5. So these are our 2 data points right here. And then what I did was added those together and divided it by 2.
Okay, just a quick question. This might be more of the Excel sheet. If you start from cell A2, that kind of bumps you up 1 because cell A1 is already taken. So are you counting from cell A2 down or from cell A1 down?
Actually, I'm doing it from A1 because I removed the headings.
Oh, okay. Okay.
So we're starting at A1.
Okay. Okay then. I just wanted to double check.
Yeah. But good eye though, you're really paying attention. So I think the answer is 68319. You agree with that, Bartholomew?
I think he's still on mute.
Yeah, can you hear me now? Can you hear me?
Mm-hmm.
Yeah, can you hear me?
Yeah, we can hear you.
Okay, I am thinking the median should be 68552.
Okay, how did you get there?
When you enter the median formula and you log in with all the numbers starting from cell 2 of the wrong side,
Mm-hmm.
and you drag it down to the last end, you will find that the median is pointing at a figure of 58,552. So that is what I can you try it out again?
Okay, 1 second, let me see.
So it's if you look here, there's an even number, there's an odd.
I'll get in a second. I'll just use the Excel function here. Okay, so when you pull equals in Excel and collect all the data and ask for median, it is given 68552.
Yes.
Does that make sense? We do have an odd number of data points, so there should be a middle number. We shouldn't have to average it out.
The standard deviation will be.
Can you mute your mic, Bartholomew?
Okay.
Thank you. Okay, find the standard deviation of the amount paid in wrong side lawsuits. Round your answer to the nearest whole dollar. Standard deviation of the amount paid. Wrong side lawsuits. All right, so how do we calculate the standard deviation?
So in Excel, just go to a blank cell and do equals. It should be STDEV, and then you set all the data that you want and hit enter. That's how I'm working this one.
Okay. All right. Standard deviation 71403 or 71404. Is that what you got?
What is that for? Oh, dang it! I was doing the patient instead of the because we're still pulling from cell A, I mean from column A, right?
Yep.
I went to column B instead by mistake.
All right. Well, you run the calculation. See what you get.
714.04 if you round up to the nearest.
To the nearest dollar. Yeah. 71404. That's what I got too. All right. Use the following information to answer the next 5 questions. Hepatic angiosarcoma is a rare and usually fatal type of liver cancer. A study was conducted on 4 individuals with this illness. The data represent their survival times in months. Okay. What is the mean survival time for these 4 patients?
I'll go put in the so we have 519.13. 519. 3 equals
What'd you get?
1 second. For me, oh, come on. Wait, mean is not an average, right?
Mean is the average.
Mean it. I'm doing double work here. Okay, never mind. I'm getting 7.
Okay, me too. Good.
Okay, but is Bartholomew there? Is he thinking something else? What is the median? Bartholomew, are you there? I hope we didn't lose him.
No, he's there. He's just.
Oh.
Yeah, I'm there. I'm trying to calculate for that one.
Oh, okay. The median I'm getting is 4. Anyone getting something else?
9, 6, 7. Nope, that's what I got too. Alright, if we were to compute the variance by hand, the following table could be used. Use this table to answer the next 3 questions. Next 5 questions. Oh. Alright, give the number that would be entered into the space labeled A in the table above. Deviations from the mean.
So 19 will be excellent. I'm going blank on this one.
Hmm.
Hello, this is Brother Cromer from the Math Department. This is a continuation of the Lesson 3 video dealing with describing quantitative data, shape, center, and spread. So now what I'd like to do is I'd like to talk about the uses of the variance and the standard deviation. The uses, it determines the average, quote-unquote, average distance. It's not exactly the way we think of an average, the average distance from all the data points. It compares the spread of different distributions. It's capable of finding percentage of data that approximately falls between certain points of the normal distribution curve, and then it determines the possible outliers. So for instance, if we, we'll cover this later, but if we have a bell-shaped curve, bell-shaped distribution, approximately 68% of all the data fall within one standard deviation from the mean, approximately 95% fall within 2 standard deviations from the mean, and approximately 99.7% of all the data fall within 3 standard deviations from the mean. Okay, and what we can do is that if we go back to, let's see if I can find, if we look at this, and we look at the mean and the standard deviation, if we take the mean and we add and subtract the standard deviation, about 68% of the data will fall within one standard deviation from the mean. If we add and subtract 2 standard deviations from the mean, which is 78, we'll find that about 95% fall within the mean. We'll find 95% of the data fall within 2 standard deviations from the mean. And almost all the data fall within 3 standard deviations from the mean. So that's an example of how we can use the standard deviation, especially with the bell curve. And so conversely, if we know the percentage, the bulk of the data where it falls within, then we can say that any data outside of 2 standard deviations from the mean would be considered an outlier, and any data outside of 3 standard deviations from the mean would be considered an extreme outlier. Okay. So now what I talk about is the 5-number summary. The 5-number.
Hey, just a minute, guys, okay? Okay, guys, so I'm back. Now, we did the standard deviation previously, and we used a formula for it. So perhaps we can do the same thing again. So here's our data. We can go .16. Anyone have any thoughts how to do this? Deviations from the mean. So let's figure out what the mean is. Okay, so that's our mean. And that's our median. Okay, so I think the deviation from the mean would be 1. Most of it is going to lie within the 8. I don't know.
So now what I'd like to do is I'd like to talk about the uses of the variance and the standard deviation. The uses, it determines the average, quote unquote, average distance. It's not exact the way we think of an average, the average distance from the mean from all the data points. It compares the spread of different distributions. It's capable of finding percentage of data that approximately falls between certain points of the normal distribution curve, and then it determines the possible outliers. So for instance, if we, we'll cover this later, but if we have a bell-shaped curve, bell-shaped distribution, approximately 60% of all the data fall within 1 standard deviation from the mean, approximately 95% fall within 2 standard deviations from the mean, and approximately 99.7% of all the data fall within 3 standard deviations from the mean.
I'm going to say 3 here. It's my best guess. So figure out what would be in B.
I'm sorry, guys. I had to step away for a second.
Okay. I don't really know how to answer number 8, but my best educated guess is that it's 3.
Let's see. Deviation from the mean. Oh, wait a second. Wait a second. Let's see. Deviation from the mean. Okay. All right. Um, okay. Got to-
The mean is 30.
So
Deviation from the mean is x.
this, I think you from what I just found out, it's the where do we go? Deviation from the mean 9 would sum up everything and then divide the sum by 19. That's that's how far it is from the mean. Does that make sense at all?
Um,
I could be
I think
wrong,
so. Yeah.
but I looked. Let me unshare my screen with you guys real quick.
Okay.
I'm right here. It says, for example, the average mean the difference between this average 3 and the value in this absolute difference being the average of these.
So they're going 6 divided by 5. I think.
I have to calculate deviation from the mean. Well, I guess I should have clicked on that, right? On this one,
Okay.
oh, we need to find absolute value of. Okay, ignore what I just said because I'm really confused now.
An absolute value of 2. Deviation from the mean. Okay, what they're doing, if you look on my screen, what they're doing here.
Let me see. Let me come back and stop sharing screen. Where do I go? Okay.
What they're doing is they're taking the data point, subtracting it from the mean, and that's our deviation from the mean.
Oh, so they take each data point and subtract.
Yes. So here, what we would do is we'd find out the mean, which is 7,
Uh-huh.
right, divided by 4. Yeah, so the mean is 7. What we would do then is go 19 minus 7, which would be 12.
Okay. Seems logical.
Okay, that's my best guess there. Yeah. Give the number that would be entered in the space level B. So in that one, all we're doing is squaring the deviations from the mean. Should be 144. Let me just double check that. Okay. What is the standard deviation of the survival times?
I see fun.
Oh, give your answer in months rounded to the nearest tenth. Seems like we're already asked that question. Was the mean survival time? Was the median? Deviations from the mean. What is the standard deviation of the survival times? Give your answer in months, rounded to the nearest tenth. 97, 98. You understand how I did that? Okay. What is the first number in the 5-number summary? Let's see, what was the 5-number summary? Minimum, the first quartile, the second quartile, third quartile, and the maximum. Find the values for a 5-number summary in Excel. Do the following.
With a 5-number summary, I've been looking at maybe the first 5 numbers that are big in it.
What's that?
I'm actually with the 5-number summary. I've been looking at the numbers that are big in the first 5 numbers that are big in that data point.
So you're saying we need to arrange from least to greatest?
So let us rank it. Let's do ranking.
Okay.
So let's rank the number from the first to the
Oh, you want us to? Okay.
Yeah, do you get what I was saying?
Yeah, you want us to rank them, right?
Yes.
I think if you highlight and go to conditional formatting, you can highlight the highest, I think. Let's see.
A little analysis here. Was the first number in the 5-number summary from the wrong patient lawsuit data? That would be the minimum, which is B0. You see, I've found this data sheet from the course material, and it's giving me an analysis of all this.
You think it'll be 0?
Yep. Was the second number in the 5-number summary.
Okay.
I'm going through the right data points, right? Where'd that go? Oh man, good thing I checked that. Wrong page. I'm doing the wrong column, so let's do this again.
Quick question. In doing this, we have to filter from top bottom.
Yeah. Okay, what we want is this data here. There we go. The minimum is still 0. So I've got the right data.
Okay.
First number. Okay. Quartile 1 will be 3,900. First quartile, second quartile, third quartile. Yeah. So that'd be 3,900. Was the fourth quartile? That'd be the maximum. 1, 2, 5, 1, 2, 0, 0, 0, 0.
Yep, that's the maximum that I got as well.
Okay. We're almost done. There we go. Redbox is an increasingly popular way to rent movies in the U.S. Individuals can go to a Redbox kiosk and have a wide variety of movies to choose from. A study was done in which researchers observed the duration of time individuals spent making a decision which movie to rent a Redbox. Okay. That was the third quartile of the Redbox decision test. Be the minimum. First, second, third, maximum.
Oh, so this is an estimate I will be given.
Yeah, I think so. Instagram, minimum value, first quartile, median, third quartile, and maximum value. What is the third quartile?
It's been a while.
Let me see. What did you get for that one?
What's the thing? I think it wasn't the third quarter like the bottom of it. I mean,
Okay. Then what I'd like to talk about the box plots are representation of the 5 meter symbol.
there we go.
So if we like to find a box plot,
Oh, the third quarter is the top box. So the third quarter should be around 180.
now we can get an idea in terms of what type of
It should be like the line that borders the green line from the top. That makes sense? Does that make sense?
Yeah, sorry, I was busy for a second. Yeah, so
I can share my screen real quick. Let me see here. So right here, let me share it. Yeah, can you guys see my screen?
yep.
See the whisker? The medium is right after the whisker, the median, and then the third quarter right here.
Okay.
And
Minimum
then
quarter.
whisker. So if you come back to the question right here, whisker, median. Yeah, so this right here will be the third quarter. So I don't know, 180, 190, wherever. I said 180 because it seemed like really close. It could be 175, but since it's an estimate,
Yeah, I agree. We'll do that. It'd be 190
okay.
and at 190. Yeah. Yeah, at 180, I'd say. What is the longest observed time of the red box customers in the study? 720.
Mm-hmm.
They're basically asking for the maximum.
Okay.
Based on the box plot, what is the value of the mean?
Oh, the mean is just the bottom of dang it, where did it go? I can find my book to save myself. So the mean will be
The mean would be, wouldn't that be
what's
this
that?
little box? Well,
It's
no,
just
the
like the
mean-
bottom of
The bottom. This is the median. So this would be the mean, I think. 105, 62, 187. 105, 62, 187.
Said if we have a median here and the minimum is further away to the median than the maximum is away from the median, then it would be a less skewed distribution. If the maximum is further away from the median, okay, now what I want to do is I'm going to pull up an example briefly here. Now, usually if for the whiskers, which is described in the online textbook, bottom part, this here normally represents the median, or excuse me, the minimum. This here represents the maximum. However, if we have stars or dots below or above those whiskers, And the lower point represents the minimum, and the highest point represents the max. So you just have to be mindful of that. I think that's primarily you have to.
That's the median. 87.
I'm tempted to say 105, but oh shoot, my other class is starting right now.
All right. 105. That's what I'm gonna do.
Yeah, I was tempted. I was thinking that earlier. I'm gonna submit, but I might not be. What the heck is this? Why is it? I'm submitting right now, and I'm gonna take off the class because I'm running late. But
All right.
thanks again for your help, guys.
Yep. No problem. I'll see you later.
Okay. See ya.